Hey, this is Mr. Beckstrom, and today we're going to go over the final exam review. So these are questions that are going to be similar in complexity and content to the actual questions on the exam. So let's get started with the first question here. And it says, using a graphing utility to approximate the real solution, if any, of the following equation. And all solutions lie between -10 and +10. And that right there is a little hint to use the standard zoom, or we can actually go into the window and set it from -10 to +10, either way. But let's pull up our calculator here. All right, so the first thing I want to do is just put this equation in my y1. So this is going to be x to the 4th minus 3x cubed minus 3x cubed. Oops, wrong button. All right. Plus 8x minus 2. Okay. Enter, and then I'm going to go to my graph, and this is what it looks like. So it looks like we're going to have two real solutions, one right there and one right there. So I can either use, I can use trace to get a have an idea where they are, but what I want to do is I want to use the 0 function I have here. So I hit second trace, I go down to 0, and it says first give me a left bound of the 0 I'm trying to find. So I'm going to go to the left side of this 0 right here and hit enter. And then I'm going to go to the right side, making sure I don't get to the right of this one, or there'll be two intersects in there and it'll error out because it can only show me one. But as long as I go somewhere on the right, so what we're telling you right now is that our intersect is between these two vertical lines. And no, I don't want to guess. And we get that intersect there, -1.451452. It looks like it's probably irrational. And they tell us to round to 2 decimal places as needed. So my first one is going to be -1.45, and comma. And now we got to find that second one, so we're going to use the same process. Second trace, find my 0. First I want to go to the left of this, making sure I don't include this one. So anywhere around here is fine. That's going to be my left bound. And my right bound, I'm going to have to go to the right side of that intersect. So as long as there's only one intersect, exactly one intersect between my two vertical lines, I'm good. And that is going out to 2 decimal places, 0.26. So here we're going to go 0.26, and that's it. All right, for the next problem, it says a professor wanted to find a linear model that relates the number of hours a student plays video games each week, h, to the cumulative grade point average, g, of the student. He obtained a random sample of 10 full-time students at his college and asked each student to disclose the number of hours spent playing video games and the student's cumulative grade point average. And right away, if I was teaching statistics, I would note that there's probably a pretty big flaw in this study, because when you're asking students to disclose a number of hours they spend playing video games per week, I would honestly believe that would be a very underreported statistic, meaning that most people, in fact my son who plays video games, don't think they play nearly as much as they actually do. So I would probably try to find a better way to calculate that, but this is not statistics. So here we want to first put this into our calculator. So I'm going to go ahead and let's get our calculator so I can see everything. Let's see if I can So that should be fine there. So what we're going to do is get out of here. We're going to go to Stat, Edit. I'm going to go ahead and clear out these two lists here. Clear, Enter. Go up to L2. Clear, Enter. And in L1, we're going to put the hours of video games per week. That's going to be our independent variable. And we'll explain that in just a moment. 4, 6, 9, 9, 11, 13. And for my dependent variable, I'm going to use the grade point averages. 3.29, 3.85, 3.54, 3.12, 3.58. All right, everything's in there. So let's go ahead and take a look at our question. The first one says, explain why the number of hours spent playing video games is the independent variable and the cumulative grade point average is the dependent variable, and choose the correct answer below. Well, the independent variable is the one that we're going to use to try to predict the dependent variable. So depending on how many hours a week they play video games, we're going to try to see if we can find a prediction of what their grade point average is going to be. So if we look down here, it looks like it's C. The number of hours is being used to predict the cumulative grade point average. So check that. All right. And, oops. Go to the next problem here. It says, use a graphing utility to draw a scatter diagram. Choose the correct one from below. So we've already put all of our data in our calculator. So now what I want to do is I want to go to second y equals. And for that, we're going to go to this first plot here. We're going to turn it on. We're going to use L1 and L2, just like it is here. And then I'm going to go to zoom, and zoom stat will zoom around our scatter plot pretty well. Let me go ahead and take that last equation out, go back to graph, and this is what it looks like. So trying to match it up from the ones here, looks like it's going to be that first one. All right. And continue. Okay, the next part says, use a graphing utility to find the line of best fit that models the relationship between the number of hours of video game playing each week and the grade point average. Express the model using function notation. So we want to type an expression using h as the variable, rounded to 4 decimal places as needed. So what we're going to do here is pull up our calculator. We're going to go to stat, calculate. We're going to do a linreg. That's a linear regression line, which is the line of best fit. We're going to use L1 and L2. And I'm actually going to go ahead and save this in my y variable because there's a good chance I'll need it later. And so I do that. Vars, go to function and y1, calculate. And so here's my equation. It says use 4 decimal places as needed. So in this case, it's going to be A, which is this value right here, times X. They told us to use H as our variable. So AH plus B, which is this number right here, the 3.3206. So I'm going to put that in here. So this is going to be A, which is negative 0.0860, and then we are going to add our B. Oh, don't forget to put the H. And then we're going to add our B, which is 3.3206. All right. So that is that part here. The next part says interpret the slope. Choose the correct answer. So taking a look at this slope here, let's go back to our graph here, and we have the line in there. We see that this is a negative slope, which means that, remember, here's our independent variable. So the more hours they're playing video games, the less, remember this is the dependent variable, the vertical axis, the less GPA, or the smaller GPA they're going to have. So let's see which one of these makes sense. If the number of hours playing video games in a week increases by an hour, the cumulative grade point average decreases by 3.3 on average. Okay, so what they're trying to do here is, this is the slope right here, and this is the intersect. So for every hour, we're decreasing this amount here, now rounded to negative 0.09. So this one is increasing. That's not correct because it's a negative, so it's going to be this last one. If the number of hours playing video games in a week increases by an hour, the cumulative grade point average drops by 0.09. So that's the slope, and so that should be it right there. And continue. The next thing says, predict the grade point average of a student who plays video games for 7 hours each week. So if we look over here, we don't really have a 7. Even if we did, we're trying to find the value that's along that line. So luckily, I've already saved that in my y1, so I can easily find this just by going to vars, y variables, y1. This says I'm going to pull up that y1 function that I already stored there previously, and I'm going to evaluate it at 7 hours. So I just put a 7 in there with parentheses, and it's going to put that 7 into that linear regression equation and pull out 2.72. Let's see, 2 decimal places, so 2.72. And check that. All right, and then the next thing says, how many hours of video game playing does a student play whose grade point average is 3.2? So now I'm going to put 3.2 in the dependent variable and then solve for the x. So what I can do with that one is, we are going to just, all right, so now I put my equation here, although this time I'm solving for the number of hours. So I'm going to replace my dependent variable with 3.2 because that represents my grade point average. And now I'm going to solve for h. So first thing, I'll subtract the 3.3206 from both sides. So this is going to end up becoming negative 0.08608H is equal to, and once again, I'm going to pull up my calculator, and we'll do 3.2 minus 3.3206, and I get negative 0.1206. So negative 0.1206. And finally, I'm going to divide both sides by the negative 0.0860. And I will get, I already have that up there, so divided by negative 0.0860 in order to isolate h. And I get about a 1.40. So approximately, I should use approximate symbols. 1.40. And pull that back up. Alright. And that does not look right. So let me check to see what I just did. Oh yeah, it does. I'm sorry. Because the 3.2 is right around here, or excuse me, the 3.2 should be right around here. So let's put that 1.4 in, and so I'm going to put 1.4. Yeah. All right. Okay, that's it for that question. Let's take a look at the next one here. It says the marginal cost of a product can be thought of as the cost of producing one additional unit of output. For example, if the marginal cost of producing the 50th product is $6.20, it costs $6.20 to increase production from 49 to 50 units of output. Suppose the marginal cost in dollars to produce X thousand MP3 players is given by the function C of X is equal to X squared minus 120X plus 8600. And it has two parts here. How many players should be produced to minimize the marginal cost? All right, so I'm taking this question, putting it in my whiteboard here, and remember this is a quadratic, a second-degree polynomial, so it is a parabola, and since the x squared term is positive, this is an upward opening parabola, and what we're trying to find is where is the lowest point, because we're trying to minimize of this parabola, and that would be the x value of the vertex. So we have a nice little formula for finding the x value of a vertex, and that is the x value of the vertex, put a little v here, is equal to negative b over 2a, where a is the coefficient from the x squared term, b is the coefficient from the x term, and c is the constant. So in this case, that would be negative. The b is negative 120, so negative 120, then parentheses, so make sure we distribute our negatives, over a, which is 1. So that would just simply be 120 units. So if we go back up to the problem, that would be 120,000 in this case. Oh, all right. Yeah, I'm sorry, I made a little mistake there. It's 2 times a, that's 2 times 1. So let me get rid of that and put the 2 in there. So go back there, I wasn't paying attention. So it's 2 divided, or 120 divided by 2, which is 60. So 60 should be the correct answer here, just forgot to do that multiplication. Go back up here and put 60. There we go. And then the second question is the minimum marginal cost is, well, we're just going to put that 60 in there and evaluate it. I could put that in my y1 function and then do the y1 trick like I did before here. But in this case, it's probably just easier to do, just replace x with 60. So that would be 60 squared minus 120 times 60 plus 8600 plus 8600. So all I did was take the quadratic that was given and put the 60, which is the that's the x value in order to minimize the cost, and I get 5,000. So the marginal cost is 5,000. Not too hard, as long as you don't mess up the formula like I did. Alright, so the next one here, it says analyze the polynomial function x plus 5 times x minus 2 times x plus 4. It says completes a through h. So we have quite a few parts here. So the first part says determine the end behavior of the graph of the function. So the graph of f behaves like y equals blank for large values of x. Alright, so when we look at the end behavior, what we really want to do is we just want to take a look at the first term in our polynomial. And we're going to end up multiplying all this together. But I do know that my highest degreed variable is going to be x cubed, because we're going to have an x times an x times an x, which is x cubed. And that's going to be a positive 1x cubed. So when we look at the end behavior, we ignore all but the variable with the highest exponent, that term. So it should just be x cubed. All right. And then now it says find the x and y intercepts of the graph of the function. Well, luckily it's already factored for us. So the x-intercepts are, you set each one of these equal to 0. So it's just going to be the opposite sign of whatever's in here. So if you have x plus 5 is equal to 0, then x is equal to -5 and +2 and -4. All right, that was nice. And then the y-intercept, we're going to let our x equal 0. So you're going to have a 5 times a -2, which is -10. -10 times a +4 is -40. So in factored form, much easier than when we have to factor. All right, determine the zeros of the function and their multiplicity. Use this information to determine whether the graph crosses or touches the x-axis at each intercept. The zeros of the function are, well, those are just the x-intercepts, right? So -5 to -4. Same as before. The smallest zero is a zero of multiplicity. That would be the -5. And it just happens once because the x plus 5 term is just to the first power. If you don't see anything there, we assume it's the first. In fact, all of these are have an odd multiplicity because they're all to the first power there. So all of them have the smallest zero is a zero of multiplicity 1. So the graph, these are all going to cross at x equals -5. The middle zero, that would be -4. Also has a multiplicity of 1. So the graph crosses at x equals -4. And finally, 1, the graph will cross at x is equal to 2. All right. Next one here says use the graphing utility to graph the function. Use the window. They give us a window here, so let's go ahead and pull this up. So what we're going to do is, let me make that slightly bigger here. Okay. Clear this out. Let's go ahead and put this function in. And I can actually just put it in just like that for right now. So x plus 5, x minus 2, x minus 2, and x plus 4. Alright, so if I put that in there, I'm going to go up to my window, table set, second window. And what I'm going to do now is change the viewing window to what it says there. So my x's go from -15 to +15 by a scale of 3. And my y's go from -60 to 60 with a scale of 6. All right. Now I'm going to go ahead and graph this. Let's go ahead and turn off our plot from earlier. All right, and here's what the function looks like. So it looks like it could cross 1 or 2 points here, but we already know that it crosses at 2 points, one here and one slightly over there. So that should be the -5 and the -4, and then again over here at 2. So looking at these graphs down here, definitely looks like this B here. And the next thing says, approximate the turning points of the graph. Round the coordinates to 2 decimal places as needed. Select all that apply. Alright, so the turning points of a graph is where it changes from either increasing to decreasing or from decreasing to increasing. So pulling up the graph here, it looks like it's increasing all the way till it gets to this point somewhere between 4 and 5, -4 and -5, excuse me, and then it decreases, and then it looks like it changes from decreasing to increasing right around 0, and then it's increasing. So our turning points should be like -4.5 and 0 for the x values. So going back over here, this is definitely the closest one there. Oh, I'm sorry. I clicked the wrong one. They are, it's this value here, and then, alright, so these are actually the points and not just the x values there. So go back here, let's go to trace. So this point down here looks around 0, -40. So that's going to be very close to this point. And then going back to my calculator, if we use the trace function and we go over to this other turning point, oops, this other turning point that we notice where it changes from increasing to decreasing, that looks around -4.5 and around 1 point something. So that is the other point. So it should be those 2 points right there, which it is. I was thinking they were talking about the x values, but these are actual points there. All right, and the next thing says, if you're wondering how many emails I get a day, it is a lot. Use the above information to draw a complete graph of the function by hand. Choose the correct graph below. Well, we already pretty much know what this looks like. It looks like this one right here. We've already kind of done it over there. So this would just be using those turning points, and increasing, decreasing, all that good stuff. G, find the domain and the range. Well, the domain is all the x values, so it looks like we can put anything we want into this function. There's no restrictions on our x values. There's no variables in a denominator. There's no variables under a radical. There's no logarithmic functions with a variable. So this should be just negative infinity to positive infinity to positive infinity. All right, and if we look at the range of this is a third-degree polynomial, so it's not a parabola. So it looks like it, for the y values, it's going to go all the way down to negative infinity and all the way up to positive infinity. So it looks like all the y values are going to be represented here. So we're going to do the same thing, negative infinity to positive infinity. All right. And the final one, it says use the graph to determine where the function is increasing and where it is decreasing. On which intervals is the function increasing around the endpoints to 2 decimal places is needed. So we can get that information from looking at our turning points here, and we show that as you're starting from the left and you're moving right, this function is going up all the way until we get to that negative 4.52. And then, so it's increasing from negative infinity to negative 4.52. And then it decreases, and then it increases from, and that was that negative 0.15 x value all the way to positive infinity. So that is right here. So these should be the 2 intervals on which this function is increasing. And then the decreasing part, that's just going to be from that negative 4.52 here to that negative 0.15. So that is this one right there. And it's only decreasing from those x values there. All right. So this is all for part 1 of the final exam review. I will go ahead and send out part 2 within the next day or so. All right. You'll have a great rest of your week, and we'll see you soon.